Argon fluoride export from people.
There's still patients here, I'm not sure.
And then,
Oh, yeah.
so we really want to know, this machine runs Windows. So the output delivery system delivers laser beam to car handlers, mirrors, attenuator controller, laser shutter when you're scanning.
Maybe some of you are already familiar with it. And what it does is, it actually does this very simple thing. So who is not familiar with Arduino? Is there anyone here that's doesn't really know what an Arduino is? It's okay to admit it? All right. So anyway, this right here is an Arduino. I'll hold it up.
Oh, I see a picture.
Oh, so that's what
There, sort of focus right now. And
First
there's something plugged into it that's a board that is a whole other story. But the thing on the bottom here is an Arduino. And an Arduino has 6 analog inputs that can be used for various purposes, can be read by the code that's running on the Arduino.
Unless it's a surface mount model.
Unless it's a surface mount, then you have 8. Depending on the model, I guess, but for at least the same chips. So anyway, there's this piece of software that somebody created called Arduino Scope, and what it does is it essentially relays those, I guess the combination of the software running on the Arduino and on a laptop using something called processing. What it does is it relays those 6 values over and over and over into the laptop so that you can look at the waveforms. Now there's a lot of limitations to this. I mean, it is no substitute for this digital scope at all. But maybe in certain applications it could actually still be useful.
Here, why don't you plug in this
So why don't we plug
sine
in...
wave to it?
Okay, so I need the sine wave brought down to like plus or minus a half a volt or so or less. I don't want too much amplitude here.
Does it need to be centered at above ground?
I will find out. It's okay if it goes a little out of range, but I don't want more than 5 volts for sure going into it.
Is the input AC coupled?
No. It is, but it can handle. Okay, so that's the other part of the story, which is I have an amplifier here. It's mostly a current amplifier.
So you wanted a half volt,
Yeah.
bipolar, or DC?
It can be centered around 0. That's fine. So are you DC coupled?
Okay, that's about a half volt. Sweep off.
And then I need a reasonably low frequency.
That's 100 hertz.
Oh, perfect.
Half a volt.
Let's give it a try. Let's see what happens. This has never been done before. Let's see what it does. Look at that.
Oh.
Ooh, it's got the chart paper look.
That's 100 hertz.
So yeah, there's no scale in the X dimension at all, which is sort of frustrating. But I imagine, since you have the source code, as with the way processing works, is you always get
So
a
we're
source code.
aliased.
So I'm sorry, say again.
So this is 100 hertz?
Mm-hmm.
So we're seeing an aliased signal.
Oh yeah, I did another thing on this, which is I brought the baud rate down.
Oh, it's not scrolling. Is it scrolling like a paper chip
Chart
recorder?
It's more like a chart recorder. This is the.
Wait, I'm gonna. All right,
Yep.
I'm gonna bring the frequency down to 10. That's 10 hertz right now. No, we were aliasing. Right, I'm gonna go down to 1.
No, because if you spread it out.
No, I'm gonna go down to 1.
Oh, there. Look at that.
So there's real time.
Okay, so it was aliasing really badly.
So maybe it has some problems that we're not aware of yet.
Well, it's only good for pretty slow frequencies. Can you speed up the time course, like dramatically?
I think you can adjust the code to do other things. So what I was trying to do is, I was actually interested in a, oh, you're right, it was aliasing.
Yeah.
Yeah.
Okay, now you need to explain aliasing.
Well, aliasing in this case would mean that you're not sampling the wave fast
Fast enough to be able
in order to
to accurately
reconstruct it.
represent it.
You're actually
So-
measuring the beat frequency between the sample frequency and the actual frequency.
Right, the plus and minus, right. So part of that is my fault in that I wasn't interested in fast waveforms when I was setting this up. I was interested in something very slow, which is the signal that comes off of a pH probe. It doesn't tend to hop around that much, but it has some noise on it, and that's what I was interested in.
How's your kombucha doing?
You know, we're not, they're growing mushrooms now, so the project is kind of on hold. Excellent, some nice waveforms here. Just keep the amplitude, you know, not too high. So. Worried.
What kind of a probe are you using?
We're
sorry.
just directly being.
So,
Yeah,
This is
over.
directly.
so this has an amplifier on the board there that level translates it into the range that.
Oh yeah,
the
so
Arduino
the Arduino has some different ways that you can look at analog signals. The most simple one you can do is basically, if the Arduino is running at 5 volts, you can look at 0 to 5 volts coming in. Now there's an option for the analog section of the Arduino where you can tell it that instead of using 5 volts as your full range, you can use this internal voltage reference, which is set at something like 1.1 volts as your full range. And because a pH probe is very, just remember this board.
Pronounced.
Fuck probe.
So old habits die hard, so I'm going to just keep calling it pH if you don't mind. So anyway, since I was interested in pH, a pH probe very roughly will put out minus 0.4 to plus 0.4. And so what I did is I said, well, why don't I just make a circuit that can do minus a half volt to plus a half volt and try to represent that pretty accurately. The reason is that you only have 10 bits of accuracy in the A to D converters, and so you don't want to have if you're only interested in that small range, you don't want to be setting the Arduino to a 0 to 5 volt range. You'll end up wasting some of the resolution.
That you'll never hear, yeah.
You'll never get up there, so I squeezed it down.
It's drifting.
Is that you doing that? That's you doing
He's playing with it.
that. As long as you don't exceed 5 volts. I think the
Or
amplifier.
5 hertz.
Yeah, or 5 hertz.
We're going off back.
So anyway, it's an interesting piece of software that is free. Arduino Scope.
Yay, processing.
What about the hardware you have on the show?
Yeah, so this, I'll tell you a little bit about this, but I'll keep it short because I think I talked about this at the last SfMicro meeting. So this board that's on here, this thing right here, is the bio board, and this was a project that we did. Basically, we're interested in measuring a bunch of things about a liquid culture, including temperature, pH, and infrared absorption. So it's got connections for some other kinds of probes, like temperature probes on here. But when I heard that we were doing an oscilloscope thing, I thought, I wonder if I can use this Arduino Scope thing. And then I thought, you know, I already have something that has a BNC connector on it. Let me see if I can adapt it to just show these waveforms. So, like I said, it's the first time I've seen a wave go into this thing, so it's nice that it actually kind of worked. The software here is showing 6 different channels. Is that it? That might be the inverter.
You can only exceed 25 volts once.
Carl?
I didn't change
Well, I can talk about XY mode.
that. Yes.
So it looks like you're finally jammed.
I have a question, Ralph.
Yes.
So how do you, did you make the Arduino Scope?
No,
Or how do you
someone
find
made
it?
this- I think if you search for Arduino Scope, you'll find it. There's a guy who created this. Let's see. It's unclear what happened.
Whoa. I like this program.